All right, you guys, I want to give you an alternate way to do some of the problems that you guys were doing yesterday in your start of 13.1. So I'm actually going to do the first in-class example from 13.1. I'm just going to do it this slightly alternate way, which I'm hoping will make a little bit more sense to you guys. I know we were having a little bit of trouble with it yesterday. So yesterday's in-class example gave us this. They said that cosine of theta was equal to 3/10. They specifically mentioned the quadrant that this angle is in. So they said that it's somewhere between 270 and 360 degrees. That puts you in quadrant 4. The reason that they mention that in these problems is because as you move around the different quadrants, x and y values are either positive or negative depending on what quadrant you're in. So for this one, for instance, if you're in the 4th quadrant, cosine is going to be positive because cosine is associated with the x value, but when you're in the 4th quadrant, sine, which is associated with the y value, would be negative. So that's why they mention this quadrant, is just to see if there's any negative signs that could end up attached to one of your trig values. So this in-class example that we did yesterday asked us to find cotangent of theta. Okay, so we're going to do the problem in an alternate way. We're going to get the exact same answer, but like I said, I'm hoping that this method will make a little bit more sense to you guys. So we are going to take cosine, take the angle, put it in the quadrant that it's supposed to be in, and we're going to label these sides. Okay, so our angle is somewhere between 270 and 360, so it doesn't matter where. Just do your best to estimate approximately where that would be. So just put it somewhere in that 4th quadrant. All right, so this entire thing becomes your angle. The important part of these problems is not what exactly the angle looks like. It's just important that it's in the 4th quadrant. All right. So cosine, remember, is the x coordinate over r. All right. So if we were to put a point right here and then kind of drop a vertical line and sort of turn it into a triangle like that, the x coordinate is supposedly 3. Okay. So I can start to label things on this triangle. If the x coordinate is 3, then we would be able to take this measurement right here and label that as a 3. So that's what we know. And then the radius is 10, and the radius is this distance right here. It's always the diagonal. So this distance right here is 10. So we took the value that they gave us, set up an angle in the correct quadrant, and then labeled 2 of the 3 sides. And then just like we did all the way through chapter 12, you have to find the missing side, and you're going to do that by setting up the Pythagorean theorem. Okay, so Pythagorean theorem to find this missing piece right here. So that's our y coordinate. That's the one that we're missing. So we set up this version of the Pythagorean theorem. We do x squared plus y squared equals r squared. X we know is a 3. We do not know y. That's what we're trying to solve for. And r is a 10. Okay, so we set up that. This turns into 9 plus y squared equals 100. We would subtract this 9 from both sides. So we end up with y squared is equal to 91. Here's the slightly tricky part that people end up forgetting about. When you take the square root, remember anytime you do that, you should have a plus or minus attached to that value. And then the way you choose it is based on this quadrant that I gave you up here. Okay, so in the 4th quadrant, your y value is negative, so we choose the negative version of the square root of 91. So I'm going to label that on there. Make sure you are definitely using the negative version. R is always positive, so if one of the values is negative, it's either the x coordinate or the y coordinate, and that will change depending on what quadrant you're in. But again, R is always positive. So now we know x is 3, y is the negative square root of 91, and then r is 10. So to set up cotangent, these are formulas that you guys had back in chapter 12. We did them a lot in 12.3. We came back to them some more in 12.5 and 12.6. This one, cotangent, its formula, and you can always double check back in 12.3 if you don't remember these. Cotangent's formula is the x coordinate divided by the y coordinate. And hopefully that's familiar from your chapter 12 test. So if I were to sub these values in, the x coordinate I know is 3, and then the y coordinate I just found out was the negative square root of 91. Okay, last thing you need to do, we're not supposed to have square roots in the denominator, so we are going to rationalize that denominator, multiply top and bottom by the negative square root of 91. You don't have to do the negative. I'm just going to do that to get the negative out of the denominator. So my numerator, when I multiply these two together, it's negative 3 times the square root of 91. And then in the denominator, the negative times negative comes back positive, and the square roots end up canceling each other out. If I multiply a square root by itself, then all I would have is just a 91. So this, let me put the cotangent back here. This is the value of cotangent. So completely different method. If yesterday's way makes more sense, do that. If this makes more sense, then do this. All right, so you guys have a worksheet that you are going to be working on, and that is going to be collected at the end of the hour.